Well, if you think it's really difficult to have further differentiation, how about this? The differentiation, you can use this way. Right? So at this moment, I reserve it. And that you think about this. Finally, if you have the result, so you can continue. But I should let you know if we can get the result so that you can have this final one. All right, so if so, that's it. Well, everything's okay with the current discussion? If it's okay, you can try and so that you can have the final result. Doesn't mean I will check all steps, or otherwise we don't have enough time. Well, if this is okay, then I go to the next one. Next one, we have waiting time. And waiting time, actually, we can have a result called Little's formula. Little's law, or Little's formula. Right, so Little's law originally should be these. Right now we have S, and so S. If so, we have the derivation already. Therefore, we have this result directly. It's really important to have Little's result or Little's formula. It's okay? So if we can have the derivation for the average number of customers in the system, then we can have time spent in the system easily. Well, up to now, is it okay? As for Little's formula, you can check the discussion previously, or maybe you can use Google Little's formula or Little's law, then you can find it should be this. Is it okay? Well, Candice, about the derivation for average time waiting in system, is it okay? By using Little's formula.
Okay.
Okay for you. And Valencia, okay for you. And Ken, okay for you. If we have Little's law. Okay. So Jason. So if it is okay, then we have this easy. And Eugene, Mila. If we have the given result, Little's law or Little's formula. So Mila, okay for you, right? Little's law. Length equal to rate multiply time. And here time. So we have the formula and just use the previous the result derived previously so that we can have the result and so that we have the final result. Right? Well, if it is okay, then that's it. All right, so actually we pass on this. So we have this result, waiting time. Well, it's okay. If this is okay, then look at this. How about Q? Previously, Eugene asked me what is the system. but this time we change system to this. Right? This time change it to Q only. If we change it to Q only, previously we have a number in Q, but right now we use system. Well, system, number in the system, we need to minus 1. Right, Eugene? Is it correct? If we use I to denote number in Q plus 1, we don't want to have a plus 1. So, of course, here we use I minus 1. Is it true? Okay, thank you. Therefore, follow the idea of Eugene. So, finally, we will have this result. Minus 1. Minus 1, but we need to have the information of I. So, we have the information of I directly. We gotta know expected value. Doesn't matter. If we want to have I minus 1, we need to get probability of I. Okay. Well, if so, you can try to have the derivation. And finally, we will have this result. And we will have the result like this. Right? Okay, so if we have something like that, we will have the result. But look at this. So, how to do? Look at this. If anyone claims mean number of customer in queue equal to number of customer in system minus 1, we can try to check. Look at this. So previously we have this, and right now minus LQ. We will have the result, right? And minus the current result, right? So finally we can rewrite. Right? So we will have this. Sorry, this is lambda. Therefore, we don't have this. We don't have a plus 1, so it's no. Plus 1 is wrong if we consider. Well, here I just want to mention, if we have F number in the system, F number in Q, the difference is not 1. Why not 1? Because you can consider the mean number in the Q. Consider mean number in the queue. Sorry, in the system. in the server. Mean number in the server, if we have 1 with a probability row and 0 with a probability 1 minus row. Therefore, the mean number in server equal to row. So that's why it's row rather than 1. Okay? Right? So if we want to have the relationship, it should be this. Ls equal to L2 plus row. Well, I have the reason to explain. All right, that's it. So let me go to the next one.